Thank you. Welcome to our Green Hydrogen Unlocked, the Brande Hydrogen project event. Thanks for joining us here today in the room and also for all of you online. My name is Monica Wood. I'm the head of communications for our service business, and I'll be moderating the session today. So after about 15 months of operating our Brande Hydrogen project in Denmark, we're now very pleased to present the key findings and takeaways today. But before we actually start with the presentation, let me just very quickly start with a quick safety moment. For those here in the room, we're in the room Nordsee, where you can see the red star. So if there is an emergency, please just walk out, take the door behind me, just take the hallway, and then take a left, and you'll see the stairs on your left. Do not take the elevator. Please take the stairs all the way down and then exit the lobby through the front entrance. So now it's my pleasure to introduce our speakers today. Our first speaker is Paul Skærbeck. Paul is our Chief Innovation Officer for Service and also a Power-to-X pioneer. He has more than 23 years of experience in R&D and technology in the wind business and also leads our technical hydrogen efforts to accelerate the company's engagement in the energy transition. Next up will be Ulrich Rüth. Ulrich is our head of hybrids and hydrogen and is the chief engineer for offshore hydrogen. He joined Siemens Gamesa in 2021. He has been working in the energy industry for more than 24 years at ABB, Alstom, Siemens, and Siemens Energy in a number of different roles and changed to hydrogen, the electrolyzer business, about 5 years ago. Also speaking today will be Bene Meierle. Bene has been working in renewables for about 10 years. He's currently the lead solutions architect in Siemens Gamesa's Global Service Innovation Department. And he studied nanotechnologies and renewable energy management at the universities in Ulm and Freiburg, Germany. And after his studies, he worked at Hamburg Energie and Ørsted in various roles. So now let's move on to today's agenda. Here you can see we'll start out with the introduction to the project, the Brande Hydrogen project by Paul. Ulrich will give us an overview of the key technical learnings. Then Bene will follow up with our key commercial learnings. And then Paul will wrap up our session with what it takes, what are the priorities to unlock the green hydrogen industry. And of course, we're also going to have time for Q&A. So we'll try to have at least 10 minutes. And we'll take questions from here in the room, but also from those online. For those online, if you have a question, you can submit those at any time. There is a Q&A field below the live stream. You can just type those questions in there. Now, without further ado, I'd like to ask Paul to tell us more about the Brande Hydrogen project and why R&D and innovation plays such an important role in the scale-up of green hydrogen. Now, over to you, Paul.
Thank you. Which button will press you?
Just over.
This one? Yeah. Okay. Thank you, and also a warm welcome from my side for this event, both the people here in the room and the people online. Before going into the Brande Hydrogen, I would actually like to start out a little bit saying what has happened in the industry and why is it really we are now talking about green hydrogen. Green hydrogen was actually something we started to look at a little over 4 years ago. And the start was really at the time we looked at what do we do with excess energy, etc. But the more we have looked into it, I'll show you a bit some numbers later. This is not about excess energy at the end of the day. If we really want to make an impact on the decarbonization, it's about massive deployment of renewables for pure hydrogen production. Of course, there are some synergies to the existing electricity grid to be made, but at the end of the day, this is a very big scale. I'll show you the numbers a bit later. The reason we are really here today is the fact that we have managed to bring down the cost of renewable electricity. And this is just to show you the journey we have been on as a company in the last 30 years. What you see here on the left-hand side is fundamentally the development on the turbine technology side in 30 years. And you see the turbines we did 30 years ago, more or less the size of the foundations we use today. So the rotors went up a factor of from 35 meters to 236, so 7-8 fold or something like that. The rating on the machines went up a factor of 30. And when we talk about green hydrogen, what I see is we have the same journey in front of us. We just do not have 30 years. We need to be much quicker. And of course, what this technology gave on development gave on the renewable electricity side was the curve you see on the other side. That was the steep decline of the prices of electricity coming out. And this is exactly why we now talk about green hydrogen, because if we had done the green hydrogen cost per kilo calculation here, it would have been insanely expensive. But with all the reductions we've done now, we're actually in reach of the grey hydrogen and other forms of energy. And to me, that's really the trigger here. That's why this is interesting now. We could not have afforded it 10 years ago. But if let's dig into it, what is the challenge really here for when we talk green hydrogen? And the challenge is the scale of things, as I mentioned already before. You see, if we look on an EU level, with all the turbines and PV and everything we put up, we have solved like 15% of the transition. If we take the oil and gas and coal-based part into it, then we are down to 3%. So we still have 97% to go when we start to attack that part of the energy market as well. So this is a huge challenge. This is why we really need to get to scale very quickly. And this is what we looked at like 3-4 years ago and say that's why we need to push this very quickly, and we actually start to build the Brande Hydrogen to see we need to understand these technologies. What will it really take to do the development like we did on the offshore turbines? And then if you look in the press, you cannot count the amount of targets for how much green hydrogen needed. This is just a few snapshots. There's one here like saying 306 million tons. I'll come back to what that means in renewable. We have another one where it says EU wants 20 million tons, etc. The targets are out there. I think what we just need, it's hard to grasp what will this really mean. And I'll show you that on the next slide here. Because 1 million ton of hydrogen, what will that mean in renewable? These are thus the three kind of sources. We have offshore wind, we have onshore wind, and we have solar. That's kind of the competitive renewables we have at the moment. And 1 million ton, we saw before 306, but just 1 million ton is 10 gigawatt of offshore wind equivalent, or 15 of onshore, or 20 of solar. So the challenge ahead of us, if we want to do 300 million tons, is just enormous, much bigger than what we have done so far on the electricity side. So we need to get going, and we need to get going quickly. And as Ulrik and Ben will say, we are trying to find the solutions for this, but there are some challenges in getting this to scale. Very specifically what we do, we're actually working in kind of three work streams or swim lanes in this area. We have what we call the on-grid hydrogen production. This is fundamentally where we go to an existing wind farm, take some of the power out and optimize the production of electricity and hydrogen. And that requires, on top of things, a kind of an energy management system. This is something we believe we can push pretty quickly into the market. The second thing we're looking at is the pure offshore hydrogen production, where we go to a full conversion on the turbine level offshore for mass deployment. And the third thing we are starting to look quite a bit into is pure off-grid operations onshore. We start to see very big projects in Australia, Chile, etc., where there are no grids. We need to find a way to connect the renewable source and the electrolyzers and make that run without having a public grid to support it with frequencies, etc. So this is fundamentally the three areas we are targeting right now and are trying to develop solutions for. But without any we need to finish this one also. Of course, this series here is, or this event is a part of a series of kind of communications we are doing about what we have achieved here, and this is the third one coming after we 1.5 years ago, or 15 months ago, made our first white paper where we said this is really what we believe it takes to come to scale in green hydrogen, and now we fundamentally would like to share what we have learned in the efforts we have done so far, and we will come with further of these in the years to come. But without further delay, I'll hand over to Ulrik now, and he'll explain a bit about the test operations we have done for the last 15 months.
Thank you. Yeah, and thank you, Paul, for challenging me, because you're talking about gigawatts, and now I have to explain the audience what we learned from a 400 kilowatt electrolyzer. So that seems to be impossible, but actually it isn't, because it is part of a design thinking story that we are running in the background. So design thinking, now not sure who heard about design thinking, but design thinking is the means of going onto a journey and adventure without having a map, without even knowing the direction, but with the confidence to end up somewhere great. And design thinking is about starting with great ideas, narrowing things down into a first minimum viable product, and then taking it from there, opening up the solution space again, and then coming to the next product. And Brande Hydrogen is our minimum viable product on this journey. And design thinking has 5 main principles. That's learn from people, that is find patterns, that is define design principles, that is make things tangible, touchable, and that is iterate relentlessly. And that is exactly what the whole hydrogen story that we have started 3 years ago is about, constant iteration. I'll come back to these points in each of my slides. But actually, what is Brande Hydrogen? It's a nice small site, in Danes would say hyggelig. So it is, we have in the core a 400 kilowatt electrolyzer powered by a 3 megawatt direct drive turbine. We have a battery with 560 kilowatt and 560 kilowatt hours. Of course, a lot of electrical connections, and then we compress, buffer the hydrogen, and then what you cannot see is there's a dispenser, and here are then the hydrogen trucks, or the trucks that carry the hydrogen to Copenhagen for fueling Copenhagen taxis. So that is the small, tiny setup that we have in Brande, and very important, and it's always forgotten in this black house in the annex, we have the control and the energy management system. That's the cash machine behind, maybe not behind Brande because that's a protected environment, but that's the cash machine for future projects, the energy management system. That's what Benedict is going to talk about in a minute. So I want to talk to you about 3 main learnings: safety and standards, hardware readiness, and supply chain and ecosystem. That's my 3 points. Let's start with the safety. So we learned a lot on the safety side. Actually, safety has always been first priority also in the wind business. The difference is that now in the hydrogen business, we are entering into a new world, into the oil and gas world. So all the brilliant wind engineers suddenly have to deal with gas. And that is a big, huge training and learning aspect. So, and it's not only about learning, it's also about bringing 2 philosophies together, because the wind industry has a totally different safety philosophy than the oil and gas industry has. Oil and gas industry has, let me give you an example from a different setup. Oil and gas industry, for example, CapEx doesn't play a huge role. So you just install things 3-4 times because OpEx or operation is the main thing. We cannot afford that on a wind turbine, especially if we go offshore. We are confined in space. So therefore, there are a lot of philosophies that clash, and that we have to solve. So we have to find safety philosophies that are that don't compromise on safety, but that also respect the new environment that we are in. So that is one of the key learnings here on the Brande side. So I won't go into any details of these documents, but what does it actually take to design a safe system? Also here, I won't go into any details, but it's 2 ingredients that are very important. The first one is know your risks, and the second one is know the standards. I start with the standards. You can see here on the right side that we have a hierarchical system of standards that we have defined. And also here, we mangle up, or we mix, or we use standards from all 3 worlds, from the oil and gas world, from the wind world, and from the offshore world. And we put that into a system where we start with the global standards on level 1, then with the system requirements and local regulations on level 2, and then with the component regulations on level 3. But we have clearly defined which standards are ruling, what are the mandatory ones, and which are the optional ones, because standards always has to be unambiguous. So it has to be clear which standard applies. And of course, we have to discuss that with our customers, especially with regard to local regulations. So that's also a journey, was a lot of iteration. Now we have that set of standards, but we will iterate on the next set of standards and adapt that in our development process. And the second thing is know your risks. So we are planning during the development process a lot of different risk methodologies. So we are applying things in the design, in the fire and explosion space, in the health environment and safety space, and of course also in the operation space. And we put that into our program. So that is our development program, that's our components. And we will repeat. So we start with one DFMEA, we will do the next level of DFMEA, and so on and so forth. So we again, the pattern of repeating and of learning from people, because we also hired external consultants that know these methodologies. So we talk to a lot of people in the industries, especially in the oil and gas industry, because that is so new, and we try to define this new wind plus oil and gas space in that way. So key learning here, definitely safety is non-negotiable, and we have to collaborate with regard to standardization. I didn't talk about that too much, but with regard to standardization, we are actually also engaged in a joint industrial project, which is driven by DNV with a lot of partners. I'm sure there are a lot of partners also here in the call today and here in the audience. And that's about defining the standards of the electrolyzers part of it. But we are taking that also with a further extended scope for everything around the electrolyzer. Next thing, hardware readiness. I made this little table. So, again, design thinking. That's our target. That's where we want to end up at the end of the journey. Huge offshore H2 production, gigawatt scale now, and also onshore mega island projects. So that's the huge target. So to get there, we have to split our work into, I called it, building blocks. So, and we have to take these building blocks and mature these building blocks over time. That means we have building blocks that are more technology focused, and we have building blocks that are more business model focused. I tried to sort them in a way where the technology ones are on top and the business model ones are on the bottom. But what you can see is that all these integration topics, process technology integration, electrolyzer integration, electrical integration, controller integration, that is something that we do in each and every step. Why? Because it's simply a technical necessity. We have to do it, otherwise the systems wouldn't run. But does that mean that we can just neglect it? No, just the opposite. We have to get better and better with each and every step, because the customers will expect us that we know how to integrate things. We know how to integrate process technology, the electrical part, and the control part. So that's a technical necessity, and we put the same teams on these projects, the same experts. So in my technical team, actually all my people are hired into projects, 100%. But we have 1 day a week where we gather and talk to each other and exchange our views, exchange our learnings. And that's how you get better from each step to each step. So that is, again, iterative and talking to people, find patterns, and make things tangible. And then there are the more advanced features, let me call it that, like black start, island mode operation. That's the things we're going to need for these island things. Also here we already started in a smaller scale in Brande with the island mode operation, but we will test that out in our third campaign in the onshore tests for our offshore development. And then last but not least, the energy management system. That's, as I said, the cash machine. That's where Benedict's going to talk about. Also here we started to already test that in Brande Hydrogen, and will also implement it in the RHU turnkey project. And just one outlook, offshore turbine, just four bullet points. So that's the idea, offshore turbine, where we're going to have optimized electricals, bringing us a lot of benefits on the efficiency side, on the conversion, so a reduction of conversion losses. Then, of course, the island mode capability. As I said, there will in the future be no grid connection, but dedicated hydrogen production offshore. Then the distributed H2 production. That sounds. What is so important about this distributed one? There are several aspects. So first of all, the scalability, because we do the whole design modular and scalable. But if you have electrolyzers, you will have a lot of heat and a lot of salinity increase. So if you distribute that over a huge field of wind turbines, it's much easier to handle from an environmental point of view than you have a point source. Also, that is a big benefit of the distributed offshore production. And of course, yeah, as I mentioned, modular and scalable design. Yeah, so key learnings here in that hardware readiness space. In order to mature hardware, you have to have it up and running. You have to touch it. You have to send your engineers there. They have to have their learnings, their retrospectives on it. And that's the main and the only way you can mature technology. You can do a lot with design reviews, but max 50% de-risking with design reviews. The rest has to happen on the field. And that's why I'm really grateful that Siemens Gamesa management gave us this site and allowed us to spend money on that, because it is not a commercial site. It is a training and learning site, and it is a minimum viable product, and it proves that it works actually. Last point, and I speed up, that's the stakeholder and supply chain and ecosystem. I'm convinced that with that new hydrogen age that we are entering, the supply chain has to go away from a classical supply chain where we order something at a supplier and then we deliver something to a customer, into a ecosystem of partnerships. So in Brande alone, we had a lot of companies involved, and we had to open our books, we had to share our knowledge, and we had to also gain knowledge and get knowledge from the partners. And I'm convinced that if we want to go that path, and if we want this path to be successful, and as I mentioned at the beginning, something great in the future, then the supply chain, the whole supply chain, from the third tier supplier to the final customer, has to be open and transparent. So that I'm 100% convinced of. So we have to start a little bit rethinking our way how we deal with each other, and we already started that with a couple of customers. So that is a very important point, I think, because otherwise we won't end up, because we are marrying so many bits and pieces of this world, so many different philosophies, and there are so many aspects that I don't know, that maybe my partner knows, or my supplier knows, or my customer knows. And that's why we have to be really open and have to have a sharing is caring mentality. So yeah, last but not least, partnerships, collaboration, that will characterize the green hydrogen supply chain. And with that being said, I hand it over to Benedikt, who will talk about the key commercial learnings.
Thank you. Thank you very much. Thank you, Ulrich. Thanks, Paul, for setting the scene, and Monica for the introduction. I will be talking about the energy management system, which Ulrich already several times mentioned that there's a lot of value in it. The business case and costs based on a case study and what it means, proving that in Brande and with our future projects. And touch upon very briefly upon the regulatory framework. Spoiler, so we just have to get going. So the energy management system, when we look at the purpose of where we want to be in the gigawatt scale, we have to have a system that incorporates the wind energy that is intermittent, that is at our core business, but at the same time we have the new components, the electrolyzer and potentially other systems like the battery, with completely new logistics on the hydrogen area. So we acknowledge that at the core of having the systems operate well, while ensuring the optimum value creation, we need to have an energy management system that takes into consideration the whole constraints. And that basically means that we have to have a infrastructure on the asset control, so on the electrolyzer, on the turbine, the exact control mechanisms at place on the technology side. But we have to have the bird's eye view on the system itself to stick to the constraints, but optimize in real time and create monetary value for that. Of course, that includes having well quality forecasts on wind, on market prices, but of course also on reliability of technology. So we have to know the constraints of the actual capabilities of the assets that we deploy. And Paul mentioned our journey on the wind turbine, but we're entering completely new ground on the electrolyzer part, and we have to consider these constraints, acknowledging that we don't have long-term reliable lifetime data on electrolyzers and batteries at utility scale. So coming to Brande, we actually test our first energy management system already in Brande. And this is our sandbox. So this is where we actually talk about protocols, data points, and we hook it up to the energy management system and have one screen where we can look at real data. And of course, we have to consider processes going forward when we scale up, but this is the basis for taking the next steps. So all the functionalities that Ulrich is talking about, that we want to have on the technology development, we already create in the energy management system today, knowing that we have to take it to further technology readiness levels. Then there's one specific tweak about our grid-connected onshore projects that I want to highlight. The battery might seem new to you when we have Brande as a project with the wind turbine, the electrolyzer, and the battery. Our energy management system, for the first time, to my knowledge at least, in the industry, we are able to bring that package together and optimize towards grid stabilization. So this is a feature in the energy management system that creates additional very high value, where we can combine the electrolyzer as a controllable load, but also the battery as an additional controllable load even faster, and ensuring high value, monetary value from grid stabilization, while ensuring that the electrolyzer is running stable. And that's the purpose of the battery in this regard. As a key summary, so the energy management system is at the core of the functioning system of a hybrid asset. And we take the first steps here on Brande and know and acknowledge that we have a long way to go yet on that. It's also about scale. And I won't go too much into detail here because Paul has mentioned that already. That's our past experience on the turbine from where we started and the need for scaling up. And we know what we've learned on that track, on making the turbines larger, increasing capacity factors, increasing annual energy production. And that's the underlying argument for our optimism, that we're able to do this. And we need to do this even faster on electrolyzers. So we need to play our part in the scale-up of the electrolyzer systems. Start with a 400 kilowatt electrolyzer, but the next one will be scale of 10 or 15 in 1 year from now, and so on. And then I just want to briefly show you a case study, which is our drawing board. So that's the piece of paper we have when we look at a potential economic viability of the Brande project. And this should just be a thought experiment and show the key principles, acknowledging that that could be updated every day today. So these figures you can see are pre-Ukrainian war and energy crisis. But what we are saying is that we have an underlying long-term business case for the combination of wind turbines and an electrolyzer supported by a battery. And we need to acknowledge that we have intermittent wind, so that's a sorted duration curve for some people that are familiar with that graph. So intermittent wind generation, we don't know at which time the wind is available and when the electricity is generated from the wind, but there's an optimum in the design of an electrolyzer. So the electrolyzer wants to be utilized to its maximum, while at the same time, the time value of electricity shown in these numbered areas underneath the graph are of highest importance for the business case. So we need to know the different time values of these energy balances, so to say, to derive the actual cost to produce hydrogen. And we do that by taking wind energy, which is already at a competitive electricity price level, but we need to also shuffle energy from one time to the other. And we also, in some cases, have to take the grid and increase the operational hours of the electrolyzer and of course, maximize the overall profitability of that business case. So in summary, there are a lot of items, inputs, and variables influencing the commercial viability, the markets, the energy regulation in the markets we are operating and where we build the project. But we tailor those business cases to the projects that we have, and the first one is Brande, where we can already deploy and validate items on that. So we have a PPA, we have a hydrogen purchase agreement in place, and on the next projects, we're even more sophisticated on these agreements, serving the further validation of our hypothesis of additional value creation and business model innovation. One sentence around regulatory framework. So of course, we need to acknowledge that a lot is moving, a lot is changing actually from week to week on energy regulation in the EU and and across the world basically. And we are aware of this, and it took bold decisions to build Brande, not knowing about the effect of a definition of is it green hydrogen or not. But now we have it operational, and we can say sometimes when we read drafts, it's green hydrogen, sometimes it's not. But we need to get going, and we have to proceed. And we need to make sure that the building system that Ulrich mentioned can create that flexibility, so we can ensure that we actually create a sustainable setup, a scalable setup, and in the end provide green hydrogen from wind on that. Yeah, that's all from my side, and then I want to hand over to you, Paul, again.
Thank you. Yeah, now we fundamentally talked about the bigger perspective, and we shared some of the learnings here and what we can do on the technology maturation, etc. But this will not do the trick. I mean, yes, we can develop the technology and make sure it's available for the market, etc. But there is a number of things that need to happen in parallel if we really want to unlock these many million tons of green hydrogen I mentioned in the beginning. And there are some, we try to list here, there are some very clear things that we need to get triggered if we're really going to make this happen. And one of the key things is, of course, this will take a lot of investments to get the capacities, etc. And we simply need to see some long-term plans. We need to see some projects of scale, and we need to see pipelines of projects being ready, because many billions will have to be invested in this. And unless we have that visibility, it'll be really hard to get the industry to trigger that. And it's really about manufacturing. We need to create a manufacturing capacity, but we also need to rethink the whole permitting process. If you look at how offshore wind is planned in Europe, it's a gigawatt here and a gigawatt there, and you need to bid for it, etc. If we're going to replace a number of these millions of tons of hydrogen, we need to kind of see continuous projects coming. It's not about bidding for 1 gigawatt this year and another one next year and hopefully win, and if you don't have anything. We need to see the pipeline. So that is absolutely critical for this to happen. The second thing is, of course, how do we connect the consumers and the production that will make of green hydrogen? So we need to see some kind of infrastructure for this. And so on the Brande Hydrogen, we take a ton at a time away in trucks. That will not be the way to go when we go to millions of tons of hydrogen. So we need to see a kind of an infrastructure across countries, and we are already seeing plans being discussed and so on, but we really need to get that triggered now. There need to be big interconnectors where you can hook your green hydrogen production up to pay something to get it transported to where your end customer are, exactly like we do with electricity. If we do not get a system like that or a mechanism like that, then it will be hard to get to scale. The third thing is, of course, the storage part of this, because yes, hydrogen is easier to store than electricity, which is very difficult and expensive. but we somehow need to have that technology developed as well. The pipelines, if there was a pipeline across Europe, that would likely be quite a big buffer where you could store for a while, but we would still need more than that. So that needs to happen, and we see technologies coming along, but it's maybe not a focus at the moment. That needs to happen as well. Then there's the whole legislation around sector coupling. How do we really get mechanisms where we can produce electricity when the grid needs that, and we can produce hydrogen in a flexible way? For example, just to give you an example, we have gotten an exemption from the grid fee rules on our Brande plant. In principle, the cable we have put between the electrolyzer and the wind turbine, we paid it ourselves. We still need to pay grid fees. Do not make a lot of sense, so we need to see flexibility on that as well. Then, of course, there is the whole market. There is fundamentally no market for green hydrogen today. There is no price on green hydrogen. We all hope it will come, etc., but there needs to be a framework so people can make a decent investment case. Like Ben said, we need to make sure there is a price on what we produce here, and there is a market for it. Then there is also, in my eyes, a very important element, which is we have the electrolyzer industry. There are many entrants in this market. We need to bring it to scale. We need to bring it to reliability. We need to bring it to something that can be mass-produced, plugged in, and it works. If we're going to deploy gigawatts and gigawatts in remote places, it cannot help. We need to have service technicians there every day. So we need to mature that technology very quickly, being able to produce it in large scale at the right cost and the right quality. That is a huge challenge, as I see it. And of course, the last thing Ulrik also mentioned, that we somehow need to get these partnerships going, especially for kind of the immediate projects we need to do. We will have a need for building projects where everything may not be in place. As I think Ben said, we built Brande. We had no idea what to do with the hydrogen initially, and so on. But we managed on the way by finding the right partners. So, and especially for the demonstrators we need to do in the next 5 years, that's super important. We get people with the right mindset in and really get this process going. So with that, I think I will stop here and open for the Q&A.
Yes. Thank you very much, Paul, Ulrich, and Bene, for your very interesting presentations. So now we have about 20 minutes for Q&A. We'll take questions from the room and also from online. So we have a question right here. Andreas.
First, thanks for the excellent presentation and the progress that you made. Yeah, thanks for the excellent presentation and the progress that you made. I have a question, and I learned from you, Paul, it all depends on the electricity cost, what the cost for the hydrogen will be. Now, we see at the moment, of course, exploding electricity costs that will hopefully go away, but generally the expectation the LCE will ever go down might not continue. What happens then to the competitiveness of green hydrogen? Will that stay or will that change considerably?
At least seen from my eyes, there is a short-term problem, of course, because the prices are very high. Nevertheless, we can build new capacity at maybe a slightly higher cost than what we saw in the past, but we can still build new wind farms with an attractive cost of the electricity. And that's, of course, why the island mode part is that there are huge areas on this planet where there are no grids, and maybe we build wind farms and solar farms, whatever's relevant there, and do the production there, because the alternative will not be to put it on the grid there. So that will be a separate business case where you build a wind farm maybe at 40 euros a megawatt hour or something, not the 400 we see on the grid at the moment. So yes, there are ways of producing competitive green hydrogen in the future.
Thank you very much, Paul. Do we have any other questions in the room here in the front? Please use the microphone so we can hear you also online. Thank you.
Yeah, again, also thank you for the presentation, and really good to hear both the progress on the technical aspects, but definitely also about the energy management system. And a question that perhaps is in your considerations, and I don't know, it's not a part of this project, but what we're interesting to understand is, we all know that the generation of heat is a part of the turbine, it's also a part of the electrolyzer process. Are you considering in the current energy crisis situation that the value of the heat being generated, either in the turbine or in the electrolyzer, should be captured? And is it possible to put a price tag on that heat being generated? Any thoughts about that would be quite interesting.
Yeah, I think the heat has definitely a value, but it is highly dependent on where you produce the heat. For onshore projects, if that is if that is close to a populated area, then of course you can reuse the heat. So I think, so I've seen a lot of projects in my former job where we had actually the question of can we reuse the heat, and it's low temperature heat, but there's a lot of heat. So therefore, yes, it is definitely worth considering heat, and in some cases even the oxygen as an additional value stream, but it's highly dependent on the project. So yeah, definitely is.
Thank you very much. Or would you like, Paul or Bene, would you like to add anything, or? No? No? Okay. Let's move to the next question. And here in the back.
Good morning, everybody. This is William Harder from Vattenfall, project manager for large-scale hydrogen generation offshore. I would be quite curious to learn about the electrical connection at the Brande project. How close did you get the electrolyzer electrically to the generator, so to say? Was that an AC connection, DC, or?
No, that's not a DC connection. So that is an AC. So that's a classical way from the wind turbine with the AC into a transformer, and then transforming it down to the needed voltage, and then putting it in the rectifier. That's the classical way, and that's also the way we plan to do it on the first generation of the offshore hydrogen wind turbines. But that's where a lot of optimization potential is in that huge chain of conversions and losses that we have there. So, but that is something we have to evaluate. That won't be part of the first projects there.
And if it's okay, I would have a follow-up question. You already showed the battery here. When we're looking at offshore turbines, they do need some form of power supply during prolonged periods of no wind. Have you looked into that aspect already? And do you therefore see a fuel cell or more towards a battery combined with reducing the standby consumption?
Yeah, we're looking into several solutions. For the first version, it's going to be a battery because that's the simplest one. But we're also considering using fuel cells because we have hydrogen anyway on the platform. The challenge only is that the fuel cell needs very clean hydrogen, and normally in our standard setup we wouldn't put any deoxo device on the platform. So that's but we are planning to run tests. Can we find a fuel cell that can run with the not so clean hydrogen? But we're looking into that, into those kind. We could also think about a hydrogen engine, for example, so a combustion engine run on hydrogen. So there are some ideas floating around. For the first version, we're going to use a battery.
Thanks, Ulrich. Do we have any further questions in the room, or do we have any online?
We have a question from online that says, how will green hydrogen affect different countries' energy independence from fossil fuel producing nations?
Did you get it?
Paul,
I'm not sure I got that question. Could you repeat that one?
Could you repeat it, please?
How will green hydrogen affect different countries' energy independence from fossil fuel producing nations?
I think if you look at it, of course, there are countries which have a big opportunity for producing green hydrogen than others. So I think there are countries that today do not have any fossil fuels that will be able to actually have a huge production of green hydrogen. So it somehow could shift the balance a little bit here. I don't know if there are any further comments.
Any further comments, or?
No,
Yeah,
I think that's
good. Thanks, Paul.
But reality, green hydrogen, you need massive amount of renewable, so it's where you can put that up.
Thanks, Paul.
We have another question, which is, do we think that the hydrogen that's produced in Brande at the moment is sufficient to, in the future, maybe warm up houses over winter?
probably not the amounts we produce at Brande today. Or maybe the house, which is here on in the background, we can heat that. But yeah, of course, there are even trials in, I think in the UK, there's a project running on trying to switch house heating, because heating is actually a big undecarbonized area. So to switch house heating to hydrogen. So there are ideas on that, and so I'm convinced that so hydrogen can heat houses. Technically, that's given. Yeah.
Thanks. And what is the hydrogen used for now? You said taxis in
Yeah,
Copenhagen?
that's now the taxis in
and
Copenhagen.
how many? I think it's
I don't
quite.
know.
It's
I don't
70 taxis, I think. So it's
We cannot fuel all 70.
yeah.
But,
So okay. Do we have any more questions? Yes.
The next one says, to have the successful implementation of green hydrogen, we need to comply with reduced emission targets. But how dependent are we on the development of large assets operating in the transport sector, such as airplanes and ships, and their technological capabilities to operate with hydrogen instead of fuel? And what is the readiness of these companies towards supporting the transition?
I can start at least on
Yeah.
that. I think if you look at these industries, shipping is mentioned. I don't think the fuel for shipping will be hydrogen in its pure form, but most likely ammonia or a derivative of hydrogen. And we already see some of the big engine manufacturers actually developing ammonia engines for ships. So that is going on already. On the airplanes, it's slightly more difficult because even Airbus, for example, is trying to develop a hydrogen-fueled plane. Still, the safety aspects, as Ulrik mentioned, is of course a concern there, and most likely we will see still the green hydrogen being used, but into some kind of synthetic fuel made out of that kerosene, a kind of synthetic kerosene.
I mean, the good thing about hydrogen is that it's always the first step. No matter what, if you add then a C using CO2 to produce green fuels or something, at the end it all starts with hydrogen. And so the hydrogen challenge is the first one we have to solve. And then in parallel, of course, develop these different decarbonization paths, so e-fuels, ammonia, industry decarbonization, heating decarbonization. That all comes, but it all requires hydrogen. So there will be a huge demand, as we have seen in the numbers. So,
Thanks,
yes.
Ulrich. Do we have any more questions here in the room? Andreas, sure. Please use the microphone.
I think, Ulrich, you explained on the HSE side that you are currently crossing borders between electricity, wind, oil and gas, and so on. Do you expect the same then on the who builds that? Will it be the oil and gas companies? Will it be the RWEs of this world? Will it be companies like Siemens Gamesa? Who will actually build this in mass? And I mean the projects, not the components.
Okay. Who will build that? That's a good question. Yeah.
As of today, we don't know. That's to be found out. We know it takes companies that are willing to invest in that ecosystem, build up of the ecosystem, acknowledging that there's no green hydrogen market or a hydrogen market in that form. So it needs these companies on the one hand side. Then on the other side, of course, we not only want to innovate on the technology, but also on the business model and value creation side. So we want to have a sustainable business going forward, take our learnings from the wind industry. So and there will be then a fit going forward.
But I think we will also see new combinations in this going forward. I mean, there are big existing companies that have also big plans in this area. But it will somehow, we need to come together in a new setup really to make this happen, as I see it.
Could indeed be consortia with companies from different business areas, so oil and gas, electricity, utilities. That's what actually is already happened. So I think probably then this consortium will build the project. Yeah.
Thank you both. Do we have any other questions here in the room? Nothing in the room? Do we have any more online? Yes, let's take one of those.
So do you consider, or would you be able to say that the current energy crisis with electricity prices going up has affected our advancements in hydrogen?
At least I can start out on that. Of course, there is a short-term effect saying taking power from the grid, making hydrogen has become a bad business case right now. That being said, I still think the fact that we have an urgent need for more energy will be the booster of this in the longer run. So I actually see there's nothing positive about the energy crisis as such, but at least for advancing this, I see this as positive, because we will need to bring new capacity online, and I'm sure that will be accelerated now. But in the short term, yes, it's of course difficult to get, especially the first kind of demonstrators going, because we will have to rely on existing capacity, and of course there is a much more attractive market to sell to than making green hydrogen at the moment.
Thanks, Paul. Bene, Ulrich, anything you would like to add?
I always compare a little bit with going to the hospital with a broken leg. It hurts at the beginning, but on long term, it's a good idea. So we are currently in hospital.
Thanks, Ulrich. Alim, why don't we take another question online?
So it says, as I understand, the produced hydrogen is currently used for taxis in Copenhagen. Can you comment on the overall efficiency compared to a battery-powered car? Do we see this as down the road in the transport tech sector as a major market for the green hydrogen?
I can answer on that. Pure electricity electricity-driven cars has definitely the highest efficiency. There is no way to reach that high efficiency, because that is just a couple of percent points losses that you have on a battery-driven car. I think the challenge begins when in transportation. The challenge begins when you go higher in weight or longer in distance, and then the battery is not the best solution. So especially. When we moved to Denmark, I talked to the guy driving our moving truck, so how much liters of diesel he uses and how long can he drive. And then I thought, okay, that's not a use case for batteries, never ever, because then you would have the whole truck full of batteries. And so I think it is the overall efficiency, if you want to know about that, so maybe it's 70% producing the hydrogen, and then the fuel cell in the taxis maybe 55%. So if you multiply these two, then you end up at something about between 40 and 50% probably. No, less even. That's probably comparable to efficiency of a normal combustion engine, if you take that into consideration. Maybe you want to add something.
Yeah, I think as Ulrich said, the problem with electric vehicles is you cannot store the energy effectively for a long time. And I think if you take, as Ulrich said, heavy machinery, etc., I mean, many applications you will need 30 tons of batteries for them to operate for a day. And that's why I say efficiency may not be the only driver, because of course you could buy all these batteries and or you could supercharge your heavy industry thing every 2 hours, but the infrastructure you need to bring in for actually doing that would be enormous. And if you look at the total cost, I'm quite confident that the hydrogen will be more competitive. And the efficiency, it's of course nice to have high efficiency, but if we can produce enough green electricity that goes into this process, maybe it's not efficiency that's the key driver here.
Thanks, Paul. Thanks, Ulrich. We have time for probably about 1 or 2 more questions. Do we have any here in the room? Last chance. If not, we'll take another one from online.
So this might be a bit interesting for you guys, but without a battery pack, how can we integrate a green hydrogen plant?
Without a battery
Without
pack?
batteries, without the EMS.
Batteries, how can you integrate a green hydrogen plant?
I can say that. So we can, as of today. The battery is not required with a grid-connected setup. Again, we started in Brande with a setup of the 3 technologies, knowing that it will be a building block system and getting the learnings out of the combination. That doesn't necessarily mean that in the next projects, grid-connected, we will need a battery. But of course, it comes with an additional value creation in markets where grid stability of the combining assets, electrolyzer and battery, are important.
Thanks, Bene. Okay, we'll take one last question. Do we have any more? No? Okay, so, well, then I'll take the opportunity to thank you, Ulrich, Bene, and Paul. Thank you for the very interesting presentation. I thought it was really great, and also the questions that we got were really interesting. We are publishing the white paper today, so you can read more details now online. Just go to siemensgamesa.com. You'll see it on the front page. You can also go to LinkedIn and find the post there with the link to the white paper. And we invite you to download it and read it. And if you have any questions, you know who our experts are. So thank you again for attending today, and enjoy the rest of your day. Thanks.